Imagine for a moment a universe so vast, so unimaginably immense, that to say it contains billions of galaxies, each with billions of stars, is an understatement so profound it almost loses all meaning. And within this cosmic ocean, statistics dictate that life should be not just probable, but inevitable, ubiquitous even. So, where are they? Where is everyone? This isn't just a philosophical musing. It's a chilling question that has haunted scientists and philosophers for decades, a question known as the Fermi Paradox. And the answers, well, they range from the deeply unsettling to the utterly terrifying. The year was 1950. A brilliant physicist named Enrico Fermi, during a casual lunchtime conversation, posed a simple yet profound question that would echo through the annals of science. He was discussing recent UFO sightings and the theoretical possibility of faster-than-light travel. Given the sheer number of stars, the age of the universe, and the concept of evolution, it seemed logical that intelligent, technologically advanced civilizations should be plentiful. So, where were they? If they existed, why haven't we seen any undeniable evidence? Why haven't they visited? Why aren't there signals flooding our radio telescopes? This wasn't some fringe conspiracy theory. This was a logical deduction from the very principles of statistics and cosmology. The universe is incredibly old, around 13.8 billion years. Our own solar system is relatively young, about 4.5 billion years. This means there's been ample time for countless civilizations to appear, evolve, and spread across the galaxy. Consider our own Milky Way, home to an estimated 100 to 400 billion stars. Even if only a tiny fraction of these stars host habitable planets, and an even tinier fraction develop life, and an infinitesimally small percentage of that life evolves intelligence and develops advanced technology, the numbers still point to thousands, if not millions, of such civilizations existing right now. Yet, the silence is deafening. This isn't just an absence of alien invasion, it's an absence of any evidence. No Dyson spheres, no galactic probes, no interstellar messages. Nothing. The silence is the paradox. To better quantify this cosmic silence, astronomer Frank Drake developed an equation in 1961, famously known as the Drake equation. It attempts to estimate the number of detectable extraterrestrial civilizations in our galaxy. It factors in things like the rate of star formation, the fraction of those stars with planets, the average number of habitable planets per star, the fraction of those planets where life actually arises, the fraction of those planets where intelligent life develops, the fraction of those civilizations that develop technology that releases detectable signs into space, and finally, the length of time such civilizations release those detectable signals. Even with conservative estimates for these variables, the Drake equation often yields a surprisingly high number of civilizations. Early estimates, fueled by optimism, suggested that there could be hundreds, even thousands, of active civilizations in our galaxy alone. So, where does the paradox truly lie? If the numbers are so favorable, why is space so quiet? This is where the concept of the Great Filter enters the conversation, and it's perhaps one of the most unsettling ideas in all of science. The Great Filter proposes that there is some immense, almost insurmountable barrier that prevents life from reaching advanced interstellar traveling stages. It's a critical evolutionary step that is extremely improbable, either in our past or in our future. Think of it as a cosmic bottleneck, a hurdle so massive that nearly every potential civilization stumbles and falls. The question then becomes, where are we relative to this filter? Have we already passed it, making us incredibly rare and perhaps even unique? Or is it still ahead of us, a looming existential threat that awaits all advanced civilizations? Our position relative to the Great Filter dictates whether the silence of the universe is a sign of our exceptional fortune or a harbinger of our inevitable demise. Let's delve into what this Great Filter might be, and each possibility is more chilling than the last. If the filter is behind us, it means humanity is incredibly lucky to have progressed this far. Perhaps the jump from inanimate matter to self-replicating life is astronomically improbable. The very origin of life, abiogenesis, remains one of science's greatest unsolved mysteries. We still don't fully understand how the complex machinery of life spontaneously arose from non-living chemicals. Or maybe it's the jump from simple prokaryotic cells to complex eukaryotic cells, a single, pivotal evolutionary step that took billions of years on Earth. Imagine if multicellular life or intelligence itself is the filter, an evolutionary accident so rare that it only happened once, here. This scenario suggests we are incredibly special, perhaps even alone. But then there's the more terrifying possibility. The Great Filter is ahead of us. This means that nearly all civilizations, at some point after reaching a certain level of technological advancement, destroy themselves. This could be through self-inflicted catastrophe, nuclear war, environmental collapse, uncontrolled artificial intelligence, or even experimental physics gone wrong. Think about our current trajectory. Climate change, the proliferation of WMDs, the race to develop increasingly powerful and potentially uncontrollable AI. Are we, right now, walking directly into our own great filter? If so, the silence of the universe isn't eerie. It's a warning. It's evidence that civilizations routinely reach a point of self-destruction. Another grim possibility for a future filter is the exhaustion of planetary resources, making expansion impossible. Or perhaps it's a cosmic event, supervolcanoes, asteroid impacts, gamma-ray bursts, or planetary-scale pandemics that wipe out civilizations before they can ever leave their homeworld. The universe is a dangerous place, and we are not immune to its wrath. Then there's the predator hypothesis, perhaps the most disturbing of all. This theory suggests that there are advanced, malevolent civilizations out there, and they actively silence any emerging intelligent life to eliminate potential competition or threats. In this scenario, broadcasting our presence to the cosmos, as we've done with radio signals for decades, would be a catastrophic mistake, a beacon inviting our own annihilation. The silence, in this context, is not just empty. It's a choice by fearful, intelligent life forms to remain hidden, to avoid attracting the attention of whatever unseen force harvests civilizations. The Fermi Paradox, at its core, is a profound mirror. It forces us to confront not just our place in the universe, but our potential future. If the Great Filter is behind us, then we are an improbable miracle, and the responsibility to preserve our unique existence is immense. It suggests that finding alien life is not just unlikely, but potentially world-shattering, confirming we are not alone. But if the filter is ahead of us, then the silence is a terrifying prophecy. It means that the challenges we face today, technological hubris, environmental destruction, societal strife, are not unique to Earth, but rather common pitfalls that almost all intelligent species encounter, and usually fail to overcome. It implies that every technological leap we make, every scientific breakthrough, brings us closer not necessarily to interstellar expansion, but to the very filter that has silenced countless others. And if the predator hypothesis holds true, then every message we send into the void, every attempt to announce our presence, is a gamble with stakes we can't possibly comprehend. The paradox leaves us with a stark choice. Embrace the hope that we are unique and special, or confront the fear that our future is already written in the silent, empty expanse of space. And perhaps, the most chilling answer of all is that the truth may be a combination of all these factors, a tapestry woven with threads of impossible luck, inevitable self-destruction, and a universe far more hostile than we could ever imagine. The search for answers continues, and with every sterile, distant planet, with every quiet signal, the weight of the Fermi Paradox grows heavier. What if the reason we haven't found aliens is because they all disappeared for a reason we're about to discover? If you want to explore more cosmic enigmas, stick around for the next video where we delve into the mystery of strange cosmic signals and what they might